Today, we're going to learn about volume of cylinders. The cylinder is represented or drawn with the shape that is here. You can see we have a radius and a height. We also can have a diameter, which is twice the radius. So what we're going to discuss is R is the radius and H is the height. The shape that the bottom uh, is that of an circle. So we're going to look at it in kind of a couple of parts. The base shape or the bottom of it will be the shape of a circle. So if we can find the area of that circle, then we can kind of stack those up and we can basically take all those individual areas of those circles and we would have the volume of the cylinder. Well, that's kind of how the volume of the cylinder formula is developed, is using the area of the circle, which is pi r squared, and then we will basically times it by h. So we'll take the area of the circles here, and then we'll multiply it by the height, and that would give us the volume. So pi r squared h is the uh, formula for the volume of a cylinder. The height, as you can see, goes here, and then the radius is squared. Now, let's look at this particular example. Find the volume of the cylinder shown below. Well, you can look and notice that we have a height of 6 meters and a radius of 3 meters. And looking at the formula, volume equals volume of a cylinder is pi r squared h. So we need the radius and the height. So with that, we can substitute 3 for the radius and 6 for the height. The radius is 3 and the height is 6. Now we're going to take the radius and square it. So 3 squared equals 9. So what we're left with is volume equals pi times 9 times 6. 9 times 6 is 54. So we have pi times 54, or 54 pi meters cubed. Volume will always have cubic units, meaning something that is times itself 3 times. So that's how you create a object, is you got length, width, and height, the volume, something that can hold something. So a cylinder with a radius of 3 and a height of 6 will give you a volume of 54 pi meters cubed. Now, if we wanted to take and not leave it in terms of pi, this answer here is what we say is left in terms of pi. Pi is in your answer. Then we can simply take 54 times 3.14, and that would give us 169.56, rounding to 2 decimal places, meters cubed. So either one of these would be acceptable, leaving pi in your answer and then multiplying pi out using 3.14. Let's look at another example. In this one, we're finding the height. Okay? The previous one we were finding the volume. In this one, we're finding the height. So find the height of a cylinder with a volume of 63 pi cubic feet and a diameter of 6 feet. Well, the equation is volume of a cylinder equals pi r squared h. So if we're to take all this given information here, 63 pi feet cubed and 6 feet for diameter, then we need to understand some of the things. The diameter is 6 feet, but we don't need the diameter. We need the radius. So if the diameter equals 6, then the radius equals 3, because the radius is half of the diameter. So when we substitute everything that we have in the volume of a cylinder, well, they told us that this volume was 63 pi, and that's what has taken place here. Equals pi r squared h. The radius is 3 because they gave us the diameter and we took half of it, which would be half of 6 would be 3. Now we're going to square the 3 and we get 9. So we have 63 pi equals pi 9 times height. Note that we've got pi's on both sides. If we turn around and divide both sides by pi, these would cancel out as such, and our pi's would go away, leaving us with 63 equals 9 times h. Now that we've got numbers on one side and variables on the other at this point in the equation, we will divide both sides by 9 because it's being multiplied. The opposite of multiplication is division. So we'll divide both sides by 9. This will cancel out, leaves me 63 divided by 9, which is 7. The height is 7. Now let's look at another example. This time we're going to find the radius. We're going to find the radius of a cylinder that has a volume of 100 pi and a height of 4 meters. Well, looking at the equation, we have volume equals pi r squared h. They told us the volume was 100, so that'll be on the left-hand side, or 100 pi, I should say, will be on the left-hand side, and the height of 4. So the 4 would take place, or substitute into the place of h. In doing so, we have 100 pi equals pi r squared h, and the h is 4. Now, we note that we have pi on both sides. Let's divide both sides by pi and then cancel out pi. What that leaves us with now is 100 equals 4r squared. Well, we do have our variables on one side and numbers on the other. So what we're going to do is the variable is being multiplied by 4 and it's being squared. So let's go ahead and divide both sides by 4. In doing that, the 4's cancel out, leaves me with 100 divided by 4. Well, that's 25. So 25 equals r squared. R is being squared, so we want to take the square root of both sides. By taking the square roots of both sides, we're left with r equals the square root of 5. The square root of 5, 25, is a perfect square. So we're left with plus and minus 5. Well, because we're talking about instead of just doing a square root problem, solving a squared equation, we're actually looking at in contextual as far as we're looking at volume. And we're specifically looking at the radius. So radius is a distance, and distance can never ever be negative. So that means that the radius of the cylinder is 5 meters and not negative 5. Remember on the Pythagorean theorem that we were looking at, we came up when we were doing square roots of both sides, and we talked about distance can never ever be negative. So that's why the negative is dropped here, because it's talking about a distance. So this concludes the initial notes on solving for a volume of a cylinder.